In this video, I thought I'd have a go at creating a heart shape out of arc paths. So here is the result, and I will show you the HTML in a minute, but let me show you a picture of my geometry. I decided there are many options I could have chosen within the arcs, but I decided that I wanted um, my circles to from which I create my arcs to not overlap. So that meant that this here, this break in the heart at the top and the bottom, is essentially sort of a vertical. I could have sort of overlapped these circles that you see here and not been quite so sort of deep in the crevice or something. But I decided I would go these circles that are uh, not not overlapping, just touching, and um, and then the lower circle that I'm sort of on the outside of, I wanted to be twice the radius, and so both of those decisions are fairly arbitrary. Um, and so, but I wanted to show you a little geometry. So if I had this radius of the smaller circle is r, and of the bigger circle is 2r, and I want to find some information about where these meet, then I drew from the center to r a radial, and I said that that was sort of theta from this vertical. And then in the larger circle, I had drew from the center of that circle to the edge a radial, and that was 2r. And if those two circles are touching, and that is they're both radial, then that should be sort of a continuous line, I believe. And so I have a line that has a length of 3r, and I can sort of create a right triangle out of this with that angle I'm interested in finding. And the opposite. So these two are parallel. So here is r. The whole thing was 2r. So this is r. And so now I have a triangle where I have the opposite of my angle is r, and my hypotenuse is 3r. So I can use an arc sine to find that angle. If I recall, it was like 17, 18, 19, somewhere in that vicinity. Okay. But I just have it in my code as arc sine, so that's why I don't remember the precise angle value. Okay, so here is this HTML. I have aligned. This is from a something previous, so I don't use this style. I have a size of 300, which is sort of half my size. So overall, this is 600 by 600. And here's this styling of that. I made the SVG, gave it a border and a pink background just for nice as a heart, I guess. Okay, I'm more interested in geometry, so here we go. So here is the SVG. It's empty. I'm going to fill it with a script, and it's just going to be basically a path. So I get in JavaScript, I get that half size, and now within JavaScript, I'm calling it M. Horizontally, I'm going to start in the middle. That makes sense. I am going to, overall, it is, the sides are 2M. I'm going to go 2/3 of 1M down. And this is where I'm going to start at this part of the heart. So that's my X start and my Y start. I decided to make my radius my M divided by 2.5, and that was just maybe a little bit of playing, trying to get it within my container. And then here is that angle, the A sine, arc sine of 1/3, as we discussed. Okay. So here we go. Starting point was X start, Y start. And then I am making an arc with a radius of r. There are these numbers that when you're drawing an arc, and the first one is the orientation, but I'm doing circles, so the orientation doesn't matter. And then, frankly, the other ones I usually just sort of make and then play around with until I get them right. There are four possibilities: 0, 0, 0, 1, 1, 0, 1, 1. I am starting at my X start, and I'm going over a radius plus another radius times sine of theta. So I'm going over, I'm finding this point here. Here's my radius I'm over, and then also the one radius times the sine of theta. That's how far over I'm going horizontally. And then vertically, I'm going down from my Y start, R times cosine of theta. R times the cosine of theta to get me how far down I'm going vertically, to find that point where those two circles, I'll say kiss. Okay. And then I'm drawing my next arc, which is an arc of the bigger circle. So 2R, 2R. Here are those numbers again. And then I am going to the same, back to the middle horizontally. So now I'm getting to down here. First I got to here, my first arc. Here's my second arc getting me to here. So I am, my second arc is X start, and then I'm doing Y start plus R math square root of 8. Square root of 8. Okay, back to my little triangle here. I have the right triangle, so I have the Pythagorean theorem. This side is 3r, and this side is 1r. And so I have a squared plus b squared is c squared. So a squared plus r squared is 9r squared. Take the 1r squared to the other side, make it 8r squared, and then I need to take the square root. So you see my square root of 8. Okay. So there's my square root of 8 to get me down here. Continue, my third arc is the other side. Again, another one of the big circles. So 2r, 2r, these numbers, and then I want to get to basically that kissing point of the small and large circle on the other side. So instead of adding r and r sine theta, I'm subtracting it. So I'm on the other side vertically, and I'm on this the other side horizontally, and I'm on at the same level vertically. Oops. And then one final arc of the small circle, getting me back to the starting X and starting Y. And I add my path. My path has that all this, my D is the big property of a path is this thing called D. There are paths other than arcs. So M is where I start. A is specifying that I am making arc type paths. I filled it with dark red for a heart. I gave it a black, and with a stroke width of 3. I don't know why, but I did. And I added it to my path. And so that was a decent looking heart made of arcs. Again, I could have made other decisions, overlapping circles, or different ratio instead of just 1 to 2. But I was fairly happy with these choices, so I thought I'd present it to you. Thanks for your attention.